Hello everyone and welcome to video number 3. So today we're going to learn more about limits and derivatives, and there aren't a lot of concepts to learn today. All right, so a recap of video 2. So first you learned about the limit, and hopefully you remember what the limit means. So this limit right over here means what f of x approaches as x approaches a. And then you also learned about the derivative, which means the slope at a point. And then you also learned about the derivative of x to the power of n, where n is a constant, and that's just equal to n times x to the power of n minus 1. All right, so the first concept we're going to learn today is the limit to infinity. So we have the limit as x approaches infinity of 1 over x. So take a guess. What do you think this is equal to? All right, the answer is 0, because if you plug in larger and larger values for x, such as 100,000 and then a billion, the result is going to get closer and closer to 0. So like it's going to be like 0.00001 and then 0.0000001, and you can keep on adding zeros. All right, and now this is a little more tricky, but I encourage you to take a guess. What do you think this limit is equal to? The answer is 0, because the denominator has a degree of 2. You have x squared in the denominator, and that's higher than the degree of 1 for the numerator. So because the denominator has a higher degree, it's going to increase a lot faster than the numerator. So therefore, this limit is equal to 0. And if the opposite was true, if the numerator had a higher degree than the denominator, then the numerator would increase a lot faster than the denominator, and then the limit would be equal to infinity. All right, so now knowing this knowledge, what do you think this limit is equal to? The answer is infinity, because the degree of the numerator, which is 2, is higher than the degree of the denominator, which is 1.99. All right, so now that you know about limits to infinity, you can learn about the number e. So e is equal to the limit as x approaches infinity of the quantity 1 plus 1 over x, all raised to the power of x. And if you want to approximate e, you would plug in very high values for x, and you don't need to be perfect because e is irrational anyway. So even if you plugged in like 10 to the power of a million for e, well, who needs to know like a million digits of e? So we're going to try to calculate or approximate e by ourselves. So let's first start with 1,000 for x. So 1 plus 1 over 1,000 raised to the power of 1,000. And you see we get an approximation of e. And if we increase x, let's say this time, let's try a million. We get an even closer approximation. So you generally only need to remember the first few digits of e, 2.718. All right, and now that you know what e is and hopefully what logarithms are, you can know what ln of x means. Ln of x basically means log with base e. So ln of 6, for example, means e to the power of what equals 6. And you can plug that into a calculator and you would get approximately 1.79. All right, and now you're going to learn about the derivatives of the following. So first, the sum and the difference rule, and this is very simple. So the derivative of f of x plus or minus g of x is equal to f prime of x plus or minus g prime of x. And the signs are the same in both cases. So if this sign is plus, then this sign would be plus. If this is minus, this would be minus. And the proof for that is pretty simple. So you start with h of x equals f of x plus g of x, h prime of x. If you remember the formula for calculating derivatives, it's equal to this, but the sign should be a negative, a minus, not a plus. Sorry, this is a mistake in the slides. And then now you can just plug in like what h of x is equal to. So h of x is equal to f of x plus g of x. And so you can replace these two with those. All right, and then now you just group these terms in the numerator like this. And then now, so this is actually equal to f prime of x, and this is equal to g prime of x. And then just like that, we've proved the sum rule. And the proof for the difference rule is very similar. All right, so check your understanding. What is a derivative of x cubed plus x squared minus x plus 1? If you want to pause the video here to give this problem a try, go ahead. Okay, so the answer is 3x squared plus 2x minus 1, because the derivative of x cubed is 3x squared. We learned that yesterday or in video number 2. The derivative of x squared is 2x, the derivative of x is 1, and the derivative of 1 is 0. All right, and now this is the product rule. So the derivative of f of x, g of x equals f prime of x, g of x plus f of x, g prime of x. And now you can use this to find what is the derivative of n times f of x, where n is a constant. So first we want the derivative of the first function times the second function, and the derivative of a constant is just 0, and then plus the first function times the derivative of the second function, and that's just n times f prime of x. And 0 times anything is 0, so we don't care about this. So we're left with n times f prime of x. So this means that if you have a constant times a function and you're trying to find the derivative, you can just ignore the constant, find the derivative of the function, and then multiply it by the constant afterwards. So for example, the derivative of 3x squared, you know that the derivative of x squared is 2x. So you can just multiply that by 3, and you get that the derivative is 6x. All right, and now this is the quotient rule, and it's a little more complicated, but it's pretty similar to the product rule. You see the numerator is the product rule, except there's a minus sign right here, not a plus. And then you divide by g of x squared. And now the quotient rule actually isn't that important, but it's still good if you can remember it. And now this is the chain rule, and it is the most important one. So the derivative of f of x, or sorry, f of g of x is equal to f prime of g of x times g prime of x. You're going to see a lot of problems in AP Calculus AB using the chain rule. All right, so first, I need to make sure that you understand what the inside function and the outside function are. So f of g of x, in this case, g of x is the inside function and f of x is the outside function. So let's take this example, the square root of x squared plus x plus 1. So what do we do first? Well, the first thing we do is x squared plus x plus 1. So that is the inside function, g of x. And then we take the square root. So that is done after we do the inside function. So it is the outside function. And so the square root of x is the outside function. All right, and then now, what does f prime of g of x mean? It's actually pretty simple. First, you find the derivative of f of x, and then you replace every occurrence of x with g of x. So we know that f of x is equal to the square root of x, and then the derivative of that is 1 over 2 times the square root of x, and then we replace x with g of x, which we know is this right over here. And then we get that f prime of g of x is equal to this. All right, and now let's finish it up. So by the chain rule, we need to multiply that by g prime of x. And now the derivative of g of x is pretty simple. All right, so then you get that the derivative of the square root of x squared plus x plus 1 is equal to this. All right, so now that you know the chain rule, try this problem by yourself. And if you can't solve this problem, then you can just watch the solution and try the next problem. But if you want to give this problem a try, then pause the video and then keep watching when you're ready. All right, so the answer is first, the outside function is x to the power of 10, and the inside function is 2x plus 1 because you do 2x plus 1 first and then take that to the power of 10. So the derivative of x to the power of 10 is 10x to the power of 9. And then f prime of g of x, you just replace the x with g of x, which is 2x plus 1. All right, and then the derivative of g of x is just equal to 2. All right, so you multiply f prime of g of x and g prime of x, and then you get that the final answer is 20 times the quantity 2x plus 1 to the power of 9. All right, so these are the derivative rules, and now there is an order that you should remember them in. So because depending on their importance. So the first thing and the most important thing is the chain rule. You're going to see that a lot. All right. And then the sum and difference rule, they're also important, but they're easy to remember. And then after that, you should remember the product rule. And if you can remember the quotient rule, then that's good. But if you can't, that's also fine. All right. Now try this problem by yourself. All right. So the solution. So you also use the chain rule in this problem. So first of all, the inside function is 9 minus x squared because you do that first. And the outside function is the square root of x because you do that afterwards. All right, f prime of x is 1 over 2 times the square root of x. F prime of g of x, you replace x with 9 minus x squared. All right, and the derivative of g of x is just negative 2x. All right, so you multiply these two together, and then you'll get that the final answer is negative x over the square root of 9 minus x squared. All right, and then now try this problem. And this problem uses the product rule. We've just determined what the derivative of this function right here is. All right, so the answer is, so with the product rule, you first want to find f prime of x, g of x, and plus f of x, g prime of x. So the derivative of x is just 1, multiply that by g of x, and then plus the first function, which is just x, times the derivative of this function. We've determined that it's this right over here. All right, and then simplify it. And then you can simplify further from this step because the square root of 9 minus x squared is the same as 9 minus x squared over the square root of 9 minus x squared. All right, and then you get a common denominator and you can simplify this all into one fraction. All right, so these are all of the derivative rules that you need to remember. And then before I end this video, I want to go over one final concept. All right, so I want you to understand like the notation of derivatives. Why can you write it as dy over dx? What do they mean? So let's just draw like a function. All right, and then suppose that you wanted to find the derivative at this point right over here. All right, and then what dy and dx are, so dx is a horizontal distance from that point, and dy is the vertical distance. All right, and now it should make sense why dy over dx is the derivative, because the derivative just means the slope at a point. And then to calculate that, you do rise over run, which is what dy over dx is. And then now dy and dx are technically supposed to be infinitely small, but if they were just 0, then you couldn't calculate what the derivative is. And also you can think of dy and dx as the change in y and the change in x. All right, and then that's pretty much it for this video, but I'll there's one final thing I want to talk about, which is, all right, so I'm going to make the next supplemental videos on these concepts. And now I know that I just made a supplemental video after video 2, but this is going to be the last supplemental video for a while, because after you watch this supplemental video, the only thing that you wouldn't know that you need to know is partial fractions from pre-calculus. And you wouldn't need to know that until video 8. So if you don't know these concepts, then I encourage you to definitely watch the supplemental video. And then after that, there won't be supplemental videos for a bit of time after that. And if you're proficient in these concepts, then obviously you don't need to watch the supplemental video. But anyways, that's it for this video. So I'll see you all in video number 4.